Exponential equations. Here's the general or standard format for exponential equation. Now remember from the previous presentation that we use f of x for y here to represent this equation is a function, and a should be greater than 0 and a not equal to 1. And that's what we said. A greater than 0 and a not equal to 1. So if you're going to evaluate a function or an equation, let's say f of -1, and you're given with f of x, which is 2 power of x. What we did, we just plug in that value. So you're going to get f of -1. Replacing x, it will give you a -1 on the power side. So 2 to the power of -1. And then evaluating that, remember you have a negative power. We have to move that at the bottom to power of +1 now. So the power changes the sign once you move it from the top to the bottom or from the bottom going to the top. And the answer is 1/2 here. Okay, so let's say you are asked to evaluate what is the answer when you have 3/4 for your x. So you're evaluating 3/4, which is 3/4, and plug that in using the same equation. It will give you 2 power of 3/4. Okay, and try to distribute the power of 3, so 2 power of 3 here, and then 1/4 means the 4th root of that number. So that would be 2 times 2 times 2, so the answer would be 8 power of 1/4. So we cannot take the 4th root of 8. We can take cube root of 8, but not the 4th root of 8. So 1/4 here means the 4th root, so it's a radical. So that would be your answer now. Or you can express your answer in radical form. You have 8 as a radicand here, and the root would be 4. So that's exactly the same answer. So this one is evaluating. Okay, now we will try to solve for x as an equation. Okay, so let's have an example for solving an exponential equation. Okay, so we have exponential equation. So let's have an example, like a simple thing that you have to remember, that the base should be the same from the left and the right in order for you to apply the property of exponents. and put the two powers equal to each other. I'll show that to you. So for example, you have 1/3 as our base, and you have x here, and the other side is 81. What you can think here is applying the property of exponents. So if you have something like property of exponents, so it's like if you have 2 power of x is equal to 2 power of 5, then you're going to say solve for x here. Then we know what is x here. So x is equal to 5. So what you're doing here, you're just putting the two powers into one equation. You just have to say x, that's the power of the left side term, equal to the power of the right side term, which is 5 in this case. Now the condition here is you need to have the same base. So the base here is 2, the base here is 2. So what we're trying to do now is think about how can we express 81 into a 3 so we can actually apply the property of exponent here. So what we're doing now is thinking about factors of 81 that would be a 3. So we can say like 1/3 power of x is equal to 3, and that would be 4 threes, right? Because when you have, let's say, 3 times 3, that would be a 9. Another 3 times 3 is a 9. 9 times 9 is 81. So now we can express our right side of the equation into exponential form. So it gives you 3 here, power of 4, because there are 4 threes there. Expressing the left side into a base 3, because we have 1/3 there. So we will bring our denominator, which is 3. Does it have a power? So that's a power of 1. We bring that to the top, it becomes 3 power of a negative 1. And then you have x there. Then we can actually apply the property of exponents. So you have the same base now, which is 3 here, and you have 3 here. So what we're doing next is putting the power into one equation. So you will get, now you have a negative 1 times x there, you'll get negative x is equal to 4. Remember, you cannot have a negative variable as your final answer, so you get rid of that negative by multiplying negative 1 to the equation or dividing negative 1 on both sides. So therefore x here is equal to, so negative x divided by negative 1, that's how we get x there, positive x. 4 divided by negative 1 here, it gives you a negative 4. And that would be our answer there. In the solution set, we have negative 4. So you can always check by plugging this in back to the original equation, and it should be actually 81. So you can use your calculator to check. You're just going to do the checking by plugging in. You're going to say 1/3 power of negative 4, and that should be 81. Okay, so 1 divided by 3. And then you raise this to the power which is x, which is negative. So that should be negative 4. And hit enter. It will give you 81. So uh, this is correct. Okay, next example. So next example, still solving for x. Solve for x. And our exponential equation here is 2 power of x plus 4 equals 8 power of x minus 6. Okay, and then we have to look at our bases here. We have a 2 and we have an 8. We cannot express 2 into a base 8, but we can break down the 8 into a base 2. So that 8 is actually 2 times 2 times 2. So that gives you an 8. So we will have 2 power of x plus 4 on the left side, and 8 can be broken down into 2 times 2 times 2. So that's 2 power of 3 times your x minus 6. So the power that you got for here should be multiplied to the existing power, which is x minus 6. That's the given power. And then applying the law of exponents. So this is by exponent property or law of exponent property. We are looking at applying the base here, and you have a base 2, so they are the same. So in the previous example, we put the power into one equation, so this powers here, and then ignore the base or disregard the base. So our answer now is x plus 4 is equal to 3 times x minus 6. And then we were going to find the value for x here, solving for x. So let's just copy the left side equation here and distribute the 3 here. So you multiply 3 times x, that gives you 3x. 3 times negative 6, that's negative 18. And then combining like terms, so you'll get x. We have to move 3x to the left side. It becomes a negative 3x here. And moving 4 to the right. So that's from the left side of the equation. So it becomes a minus 4. And then we have now negative 2x. X minus 3x is negative 2x. And then negative 18 minus 4, that should be a negative 22. And then we divide negative 2 on both sides. So we can get rid of negative 2 and isolate our x here. So this cancels out. What's left is x. X is equal to negative 22 divided by negative 2 is a positive 11. And in the solution set, we have a positive 11. And that would be our answer. To check again, you plug in 11 here and replace the x there on the given equation. Then that should be a true statement. If that is not true, remember your answer would be an empty set. So it should be true, so you can put 11 as the solution for this problem. Last example. You're given with 3 power of 2x minus 7 is equal to 81. Now, as you can see, we need to manipulate the equation. You have 3 here and you have 81. So the two bases are not the same. So we need to express 81 into a base 3. So we can do that. Remember, 81 has a 3 there, times 3, times 3, times 3. So this one is a 9, and this is a 9. So 9 times 9 is 81. So we can use 3 there to match the left side of the equation. So we will have to copy the left side. And then on the right side, I can express 81 into a base 3. So there are 4 of those 3. So that's a power of 4. And then now I have my same base, 3 on the left and 3 on the right side. So my exponent property, I can put the uh, power into one equation. So I will say now 2x minus 7 is equal to 4. And then I have to solve for x. By moving negative 7 to the right, it becomes positive 7. So 4 plus 7. Divide by 2 on both sides to solve for x here. 4 plus 7 is 11. Divided by 2, 11 divided by 2, it's not an exact answer, so it's a decimal value. So you can have this as a fraction. Or you can just put this in your solution set. Okay, so don't forget to check also by plugging in 11 over 2 to the equation. Now, this is our solution using um, property of exponents or exponent property. But if you happen to have a different base, or you cannot express 81 into a base 3, so let's say you have an 80 there. So if that is the case, then you cannot apply the property of exponent there. So the second solution here, okay, so if that is the case, would be taking ln on both sides. So when you take ln on both sides, you will have ln is the natural log, and we will have this on the next section. So this is just an alternate solution here in case that 81 or not 81 is on the right side. Could be 80, it could be 82. So there's a problem there expressing that number into a base 3. So let's just do the second solution here so we can check also if we did the right thing. So taking ln on both sides, we have to remember we apply the log property here and move the power here to the side of ln. So we will have now 2x minus 7, and then you have ln 3 here, and then equal to ln 81. And then try to get rid of ln 3. I'll divide ln 3 here on both sides. And then after doing that, this cancels out. I'll get 2x minus 7 is equal to ln 81 over ln 3. Okay, and then you move negative 7 to the right. Then you will get only 2x here is equal to ln 81 over ln 3 plus 7. Okay, so we can evaluate the right side of the equation and then see if we can have an exact answer. So let's take ln, use your calculator. You have the function ln there, natural log, in your TI-84 or TI-83. Okay, press 81 divided by ln 3. The answer is exactly 4. So this one here, the expression here is exactly 4. So 4 plus 7 is 11. So this one is 11. And then you divide 2 on both sides. Then our answer is 11 over 2 still. So that would be our answer. So in solution set, 11 over 2 is the answer. So the second solution here, or the alternate solution, can be used if there's no way for you to express your number here like 81 into similar base here. And that would be our alternate solution. You can use that if you have trouble finding the same base. Okay, for now, we're using our property of exponent here to match up the bases, and then we will get the result. So this is our solution 1, and this is our solution 2, which we're going to use that in the next section.